Thank you. Goodbye, everybody. We're gonna start today's webinar first by saying that the idea of the topic we have selected is because we want to start combining, we want to start drifting away a little bit from the more technical side of what we usually do in machine learning, data science, and start talking about business applications and how this can affect different businesses, real life applications. So that's extremely valuable if you're considering a data science career. Not just the technical side, understanding what a probability distribution is, but also understanding how that can be applied. As Brandon was saying, just sign up for our course if you're interested in learning more about data science. We have all our courses in there. Everything that can be a prerequisite for this webinar is going to be there in a form of a course with practice, with projects, etc. This is for people that are just getting started with data science. There will be a few things you might not understand at first. So we're going to be using a few libraries, like, for example, Pandas, NumPy, SciPy, scikit-learn. It can get you dizzy pretty quickly. The idea is for you to focus on how we approach the problem, how we approach the concept of building a technical solution to aid on a business application first, understanding business requirements, and then using the technical side of it for that purpose. So again, if you don't understand the libraries, if you don't understand what we're doing in the process, of course you can ask. I will try to answer all questions, but again, remember that it's just a technical side that it's very simple to learn. You can just go to your courses and you're going to learn it. The important part is understanding how that can be applied to a real business application. So to get us started, I want to start with, you can, by the way, all this is published on my GitHub. It's Machine Learning for Business. It's the name. We can probably put that in the chat, maybe, Brittany. I'm going to send it over Slack later. But basically, the idea is that you can fork these repository and follow the lesson as we have it. At the beginning, I want to introduce with a real example, actually two real examples. And the first one is about Walmart and how you can, of course, read the whole text. Basically, in 2004, when a hurricane was approaching Florida, they used data science to predict which items they should oversupply, let's say, the stores before the hurricane could hit. And this is a very, very clear business application of data science. We have a hurricane coming. We can't do anything about it. We have this situation. What should we do? What should we bring to the store? Because we know we want to anticipate people buying. And you could say something like water, like supplies, but the idea here was that they run a data science process and they found that the things they needed to bring were things like, for example, strawberry Pop-Tarts and beer, something that could be unpredictable. And of course, that proved to be true. There is a New York Times piece here you can follow. But again, it's something that can be counterintuitive for a human being, was correctly predicted by machines. And this is 2004. It's not even close to today, where we have, of course, machine learning pretty much everywhere. And the second example is Target. It's also, there is a linked piece here if you want to learn more about the process. But basically, Target was predicting the behavior of their customers by understanding their purchasing habits and what they could recommend to them. And the funny story here is that Target realized that a woman was pregnant even before her entire family. They started recommending these products to purchase that were related to her pregnancy, and not even the family knew about it yet. So that's how, and again, this is just an application. It can be funny, it can be creepy, however you want to say it, but basically it's the power that we have by using data, right, to improve our products, okay? And that's going to be the subject of our webinar today. So the first notebook, I will completely ignore it. The only thing that I want to tell you is I'm going to open here the data set we're using. Oh, seems like the page is down. Give me 1 second. Well, There you go. IBM page was down. But basically, the data set is related to a telecommunications company. And basically, they wanted to predict customer churn. So people sign up for their plans, internet, mobile plans, and they wanted to predict who could be potentially, right, considering leaving the service. So they could send them an offer, send them a representative to understand what was going wrong with their service. Why could someone decide to cancel their subscription? And that's basically what this data set has. These are all the columns that we have: customer ID, gender. We have a lot of soft information about the customer. This is very good, right? So gender, if they're a senior citizen, if they have a partner, how many people dependent on them, the tenure, the entire period, right? They've been with the company, or the length of their service, etc. If they have a phone service, if they have multiple lines. So we have all these sort of soft information, all these categorical values that we're going to use alongside with some numeric values, of course, to predict if someone is likely going to cancel their service in a given time frame. So that's going to be the business application that we have right here. We have data. We want to predict that someone is going to be canceling their service. In that way, again, the business then knows what to do, but potentially they will be sending you an offer, sending you an email, or getting a call from a representative, something with that information and that prediction. The first notebook is all about data cleaning. So I'm going to just go through it. I will not explain much, because it's when things get very technical. And again, if you don't have a background in data analysis and data cleaning, it might be, I don't know, complex. We have an entire course about data cleaning in our offering, so you can just go and check it there. We follow the same process, kind of a checklist of things to clean, pretty much. But it will let us start understanding a little bit more about the data set. You can follow this notebook on your own. What I do want to focus on, and I will not be executing this notebook, I will just be showing you the data. So again, we understand the data set a little bit more, is the analysis we're going to do of these data sets. So this is what we have. Again, for all our customers, we have how many? 7,000 customers around the number. We have a bunch of categorical data plus tenure, which is going to tell us for how many periods they've been active, right? The tenure of the customer. And again, all these categorical values will be extremely useful for us to predict if someone will be likely canceling their service soon. So again, you can check this on your own. We're going to focus on a few important values. And first, if we start our explanatory data analysis by understanding first the predictor or the Y variable, which is if they have successfully churned or not. All right, so that's what we usually start with. We want to predict if someone will churn or not, so we need some testing data set. This is what we have. With that predictor, or with that Y variable, we're going to start analyzing and see if we can predict that with a machine learning model we're going to create on our own. So the first thing we see here is that the data set is not balanced. And this is an important concept. It's going to be an important concept both for the real life significance of that not all our people will churn. That's a good thing for the business, right? It's a kind of a healthy business, we can say, but also because your machine learning models will be subject to that imbalanced initial data. All right, so it's something you have to consider. What we could do here is we could make it balanced. There are different ways to shuffle the data, and this is the whole data preparation process that we use before a machine learning process when we started. And you can find in the data cleaning course and data analysis course, we talk about it. And it's important to understand how we can pre-shape the data before fit it to a machine learning model so it can perform better. In this case, we're living as it is because we understand that churning is something that is less likely, and by nature, this data set's going to be unbalanced. So that's fine with that. And then we're going to see a quick distribution of the tenure of our customers. We see them pretty well distributed, right? From 1 month with us or one period to 60, 70 periods. And that means that our data in that side is pretty well balanced. if we get marketing to tell us that they want to train this machine learning model to predict if a customer is likely to cancel, and they give us a data set that has everybody on their second period, for example, and this be just a gigantic column focused on the second period, plus a little bit more here and there, that's gonna be very imbalanced. And we're gonna say, this is, I mean, I could run a machine learning model for you, but with this input data, we will not have enough information. I need something that is representative of our entire customer base. And that's what we find here in Tenure. So that's something good. How is churn affected by tenure? Remember, again, we're here doing an analysis. So we're always looking at the churn variable or column. We're keeping our predictor there, and we're starting an analysis through or with that predictor. That's the important part. We're gonna, after this, in our third notebook, we will actually get rid of churn and we will try to predict it. In this case, we're using it because it's actually data we have. How is churn affected or cancellations affected by tenure? And this is something very clear, right? Right as you see this chart, you will see that churn tends to happen a lot more at the beginning of the lifetime of a customer with our service. So a ton of that churn happens before their 20th period, right? So that's kind of telling us something, and we haven't run a single machine learning model here. We're just doing all data analysis, and we're starting to see a few trends. Again, all the churn seems to happen in the first month. If we actually, something you can do, if you can measure, right, kind of the area under these curves, you're gonna see that a lot of churn happens in these first 4 or 5 periods. So it's something that you have a very good actionable thing for your marketing department without running any machine learning. You say, hey, start paying attention to your customers in the first 4 or 5 periods, and you're gonna get 80% done, right? So that's an important thing just by doing data analysis. A few more charts, again, indicating churn and periods pretty much in there. Something interesting, and here's when we start looking at all these categorical variables that we're gonna be using, is understanding the type of service they have. We could start splitting this data set of customers into people that have DSL, people that have fiber, or people that have no internet service whatsoever. And then understanding and treating each one of those features, right, of the service as different service units. If we treat people with fiber differently from people without internet whatsoever, we're gonna have different results, and it could help our model if we need it. In this case, we see that most of the churn happens with the fiber optic service. So there is also something telling us in there. And of course, this is something that the machine learning model will pick very quickly when it has to predict churn. More data related to that. Online services, what online services our customer have. And I recommend you, if you can, again, clone the repository and work or run these notebooks to try to understand this code. It's what we usually do in data analysis. We transform the data, we reshape it in order to analyze it better. So I'm gonna skip all over this, and I'm gonna give you this chart that is just basically what online services our customers have decided to get from us in order to understand it from their churn. Right? So we see that people that have no services tend to churn, turn to cancel, right? So that's, I can make 1,000 guesses there, but again, that's gonna be an important categorical variable for the model, and the same thing for, this is pretty much the same thing displayed in a box chart. We have a question from an anonymous attendee that says, if we offer a course path, and we do have learning paths in data science. Right now, it's a single learning path, which is the data science one, but we will quickly start expanding it to get people interested, for example, in data analysis, machine learning, deep learning, etc. So yes, I'm answering this now. This is covered in our platform. All right, moving forward, and again, Q&A section is open right there. I'm gonna keep an eye on it, so just fire whatever you have. the analysis, we haven't written a single line of machine learning code yet, and we have a pretty good understanding of the business. Granted, these data sets, it's already clean. There has been a ton of work put already to generate this data set. But as we said, there is enough information here to understand a little bit more how everything is going to work, right, in our company. And again, there are a few clear things that are going to be also represented when we run the machine learning model. If they have services or not, if they have fiber or not, the period length, all that is going to be present in the machine learning model we run. So the first model we're going to use to get things and sort things from a simple place is going to be using decision trees. And I will execute this. We're going to run this notebook live. Don't worry about these warnings. Something happens all the time. And basically, a decision tree is a machine learning model, but is this sort of, we could say, deterministic, very simple to understand, a highly interpretable machine learning model. It's on the side of the statistical learning models. It's not what we usually call deep learning, that there is something in the fifth notebook. It's a very simple, and again, interpretable. It's actually, there is an entire field in machine learning, which is the interpretability of a machine learning model. There are machine learning models that work very well in practice, but it's impossible to understand how they work. Like for example, Tesla's self-driving cars, they have very advanced models, and you see the car driving itself. But when you want to understand what it's doing, it's very hard to understand what it's doing, what decisions it's making on the fly. In this case, the decision tree is actually a very simple to understand model. Once we see the decisions that it has taken, we're gonna clearly understand why, right? So let's get started. We're gonna load our data. We're gonna replace a few categorical values with what we call dummy variables. So yes becomes 1, 0 becomes no becomes 0. Sorry. So we're gonna basically getting rid of the letters here, if you want, and just turn into dummy variables. We're gonna do the same thing we're gonna drop total charges. We're gonna make the same thing for a few other variables, like for example, the internet service that they have. So this is, I'm gonna look here. There you go, internet service. So what we saw in our data analysis is that the company provides 3 services. Where are they? Right here. Our customer can be part of the fiber plan or the DSL plan, or no internet service whatsoever, just telephone. We want to turn these from strings, from categories, to what we call dummy variables. So these 3 possibilities, right, actually become 3 different variables: internet service VSL, yes or no; internet service fiber optic, yes or no; and internet service no internet service, which is 0, 1, again, yes or no. So we're going from a string variable that cannot be processed by a machine learning model to a numeric variable, 1 or 0, that can be indeed processed by a machine learning model. And here it says the same thing, right? So if I could, let me see if the entire screen gives me, I know it doesn't work, but basically, what is the internet service? Well, it's not here, but basically, if this person has the internet service was DSL, we're gonna see a 1 in the DSL column, 0 in fiber, 0 in no internet service. And the same thing here, this person had fiber, so in the regular column, it's gonna say fiber, but in here, it's gonna be a 1 here and 0 everywhere else. We're turning a categorical variable into dummy variables or dummy columns. So that's what we're gonna be exporting here in our data set number 2.csv. So this is where the machine learning model process starts. And again, I'm saying machine learning, we're using this very simple decision tree, but it's going to let us understand the process that we are following. The first thing we're going to do is we're going to separate our data in what we call a train and a test data sets, okay, or subsets of our entire data set. Remember that, I'm going to go back again to our original data set. remember that we already know for the 7,000 customers of our original data set if they have actually turned or not, if they have canceled their service or not. We know that. We are trying to build a machine learning model based on that historical data. So what we're gonna do here is we're gonna split this entire data set, for example, in half, and we're gonna get rid of the churn variable, right? And we will try predicting with that. And then we're gonna put back again the churn variable and say, what did you predict here? Churn positive. What was it? Churn positive. You did good. What did you predict in the second one? I didn't predict churn. It was 0. And what happened in reality? It did churn. So then you fail. It's basically getting rid of the variable, training the model, testing with it, and then understanding if the model is basically predicting things correctly. So this is what we're doing right here. We're using a method from scikit-learn, which is train test split. We're gonna be breaking it into 2 data sets, and we're gonna, from those 2 data sets, sub-data sets that we're testing, we're separating the predictor, the churn variable, from all the other variables, the one that we want to predict. And that's why we have xtrain, xtest, ytrain, and ytest. And here we're setting the proportion of testing values to just 20% of the entire data set. That's what we have 5,000 customers in the training side, and we have 1,400 in the testing side. So this library is already installed. You guys can run it if you need it. But basically, we're going to be building a decision tree. And let me run these cells, and I'm going to show you what it does, right, before. There we go. I'm going to build a very quickly decision tree with the decision tree classified from the scikit-learn module. And I'm going to train it using our training subset. And then I'm going to predict with the testing one and say, what's going to be your prediction with this very simple, and actually, let me show it to you in a graphical way so you understand a little bit better. There you go. This is the decision tree that I built. This is where we're literally running machine learning here. This is a very simple application, granted, but this is machine learning, what we're doing right here. It's basically just one level of depth for our tree. Can you predict churn or not? And this is the prediction we have. And the score of this model, just with one variable, is pretty good. We get 75% accuracy with this model. 75% accuracy with a very simple decision tree. What do we have here is the only variable, and this is where we have, when we let the computers do something for us. If I look at this, let me go back again to the analysis side. If I tell you, you have to pick one variable, only one variable out of this entire data set, and try to predict churn out of it with one variable, which one is going to be? And you could say, well, if the person has fiber optic, that seems to be like a good predictor of churn, or actually if the term of the period is above something. So what's going to be? And what the machine learning model found was that if they had a plan that was 1 year or a yearly plan, that was going to be less likely to churn. So the machine learning model, looking at all the variables, decided that the contract variable right here was the most important one. If the contract month to month is 0, basically, so that means that the contract is yearly, then there's no gonna be churn. And it found it that 75% of the time that held true. So that's the power of machine learning, letting us understand things from a different angle. In this case, we haven't even talked about contract, and the machine learning model found it. So this is pretty unrealistic. Running a decision tree with only one level is pretty unrealistic. So let's keep digging and let's keep using, let's keep working with all the levels we can with the decision tree, and then we're going to jump to other machine learning models, like, for example, support vector machines and a few others. So working with a decision tree right there, let's run a few more examples right here. Two levels. If we can have two levels and we can let the machine learning model decides by two levels, now things are going to look a little bit different. It will keep looking at the contract month to month. It's going to say, hey, if you want to predict your customer churn, let's start first with month to month contract as usual. But then if the customer is on the month to month plan or not, the second most important variable becomes if they have fiber optic or not. Okay, so in this case, we find that this model with now two levels has a worse score than the one with one level. And this is something that can happen. Don't worry, we're going to keep improving it. But basically, what we see here is that we have a 0.65 accuracy, 65%, let's say, accuracy in our model. We have another question. If you have data, then you can import that in Tableau to generate business insights. I don't know if you can see the question. We have a question. It says, if you have data, then you can import that in Tableau to generate business insights, trends, and take action accordingly. What machine learning is doing here other than that? Well, again, we're using the simplest machine learning model ever, which is the decision tree. And the first thing that I'm saying here is, again, it's revealing a few interesting variables that you could possibly look at with some trend features in Tableau, but this is a categorical variable. We can't run a seasonality trend or anything with categorical variables. That's why a decision tree makes a lot more sense. So, I mean, you can use Tableau. Tableau is a great tool. What we're doing here is we're using Python and all the power of all the libraries associated to run our process. What we're doing right here in the fifth notebook, we're going to be doing it with Keras and TensorFlow, right? And that's when again, Tableau gets limited if you want. It's a great tool, but here we have a lot more power, in my opinion. What services is this? There's another question, sorry, I might have missed that. What service is this for that customers are using? I don't know, I don't understand the question, sorry. The service, it's the data set comes from IBM, from one of their customers. Okay, so let's keep digging a little bit more. We're gonna use, we're gonna keep advancing, we're gonna keep growing the tree. And we have contracts month over month right here. Step 3, sorry, I missed it. When we'll let the tree grow bigger and we add one more level. In this case, we went from one level, the basic, right, that we had a 0.75 accuracy, 75%, to something that is now 3 levels and has a 0.74 accuracy. In between, we gave it 2 levels as a limitation, and we got a 0.65. So you can see how, I mean, this is not perfect, and you have to experiment. That's the idea of machine learning. So in this case, when we let the tree grow for another level, what we're saying right here is that first variable, as usual, is month to month. If the user is on a yearly plan, so that's going to be here. Sorry, this might be confusing. It's basically month to month, less than 0.5. That makes it 0. So that's yearly here. If they don't have an internet fiber service, if their tenure is greater than this thing, or if the contract over a year is greater than, so we're saying it, find other variables that are important in order to predict if they're gonna churn or not. So what we're seeing right here, and I'm gonna move now forward with other machine learning models like a logistic regression and all that, is that the machine learning model we run is, in this case, is more closely related to an advanced data analysis process than actually a machine learning predictive model. I couldn't use this model in production. Seriously, I am just running this so I can show you how the computer can understand things that we might have oversee at the process of understanding the data. I would say that what we're doing right here is data analysis. We keep understanding our data, but now running a machine learning model. So now let's go actually modeling and predicting things. So I'm gonna restart and clear all these things. We're gonna load our data set. This is the one we created the dummies before, and scaling down some data, exporting it, splitting it, and now we're gonna use a logistic regression for this. And why we're gonna start with a logistic regression is the most common, or not the most common, the most basic model we can use for a classification task. This is a classification task. We have a customer and we have to predict if they're gonna churn or not. Logistic regression is very related to a linear regression, has a pretty similar model, but it just uses a different activation function. In this case, we're gonna just use a few standards from scikit-learn. If we fit the data, we have just split. It's the same split that we did before. I'm setting a random state, so we have the same values as before, where a decision tree had a 0.74, 0.75 accuracy. The logistic regression out of the box, without tuning anything, just standard 3 lines of code. This is your machine learning right here, 3 lines of code. It gives us a 0.80, right? An 80% accuracy predicting if a customer is going to churn or not. Again, out of the box, 3 lines of code, you have an 80% accuracy. Remember that we have an unbalanced data set. Always remember that. And what is it telling you? What we're doing right here is what we call a confusion matrix. It's basically, what's the, I'm going to say probability. It's not the probability. What's the likelihood of a customer churning? And something else is, what is the prediction compared to different states. So we know that this customer did not churn. How many did we predict that with no churn? 88%, right? If the customer did churn, how many did we predict that they churn? 0.57. So this looks a little bit low, right? So these are these diagonal we have right here is kind of the reality and all the true values. Someone that did not churn, that we predicted that was not going to churn. And we have a 0.88 here. And this is someone that did churn, and we predicted that they were going to churn. What we have here on the left, in this side right here, this is what we might be worried about, because we're saying the customer did cancel their service. In reality, they did cancel their service, and we predicted that they were not going to cancel the service. And that was a 40%, right, error. So that can be high. That's what we're going to analyze here. So let's talk for a minute about other models, and then we're going to understand a little bit more about these type 1 and type 2 errors and see how can we fix that in this case. So this is going to be a support vector machine. Okay, it's a completely different machine learning model. It's also a statistical based model, so it's simple to understand with math. We're not getting to deep learning yet. And I just set a few parameters here, but you can think again, this thing is pretty much standard out of the box what scikit-learn has. Only 2 parameters what scikit-learn has, and we have an 0.80%. So again, very good score out of the box, default one. And the confusion matrix shows pretty much the same thing that we had before. We have people that did not churn, but we predicted that they were going to churn. Again, this can be explained also by the imbalanced nature of the data set. So that's an important thing. But moving forward, that's what we're trying to do. Other model, let's keep trying different data science model, machine learning models with from scikit-learn. Out of the box, we got also a random forest classifier, which is related to the decision tree. In this case, going to be a random forest. And let's just run it as it is out of the box, and we get a 0.79 score, pretty good too. And we see pretty much the same issue. This here is always the big problematic issue. We know that did cancel, but we didn't do anything about it. We actually predicted that they were not going to cancel. So that keeps being our problem. Let's try a neural network. Do you guys know what's the fancy network, a fancy name for a neural network? It's a multi-layer perceptron. That's what we're going to run right here. And out of the box, we use the MLP classifier model, just a parameter to make it faster. And we have an 81% accuracy once again. You can see that all the models are there, 0.79, 0.81, they're all in that range. Pretty good, right? Just, 80% with 3 lines of code, you're doing machine learning, that's interesting. And again, we have, in this case, it has improved a little bit here, but again, that's the big issue that we're having. I think we have a question. Is this streaming service users? Oh, so the data set, we have a question. The data set we're using, and I think it's right here, it's the link. The data set that we're using is a telecommunication company, think Verizon, that is trying to predict churn from their customers based on what services they have. So let's talk about things that might be a little bit more technical. I will actually skip about this for a second, and I want to focus on the 2 types of errors that we might have, right? A false positive and a false negative, right? When we say to someone that is not going to churn, for example, we say, hey, you're going to churn, we predict, and you tell that to marketing, they pick up the phone and they say, hey, we have detected you're not happy with your service. And then on the other line, they're going to say, no, I'm actually happy with my service. That's a wrong prediction. So that's a type 1 error. And on the other side is, and this might be the more problematic, is when someone is actually going to cancel and our machine learning model predicts that they're good. So marketing don't, or support or whoever don't call the customer, right? So those are the 2 errors we might have. And here's when the business application part starts. And it's when it's important. If you can always tune these numbers, right? They say, hey, I'm having an issue right here and I'm having an issue right here. These are my 2 type problems. This is a type 1 problem. I predict they're gonna churn, but in reality, they were not thinking about canceling. This is a type 1 problem. We have a very small number here. So worst thing scenario is, marketing or support are gonna call the customer and say, hey, we notice you might not be very happy with your service. And the other side of the line, they're gonna say, no, I'm happy with my service. That's it. Thank you very much. Talk to you later. In the other extreme, we have someone that is likely going to churn or cancel, and we don't call them. So that might be a problem. That's what we're gonna try addressing in this following section. So we're gonna keep our multi-layer perceptron or neural network. We're gonna keep using that model. And we're gonna use this predict probability method. And I have another question here. We should have use case first, which describe the problem we are trying to solve. How machine learning is going to help us in? I'm going to leave this question here and we can go back to that in a second, kind of prerequisites. I'm gonna move forward with this so I don't lose track of what we were just saying. Again, what we're doing right here is trying to predict churn. We're using machine learning for that, but we're not just blindly applying models as we were doing. We will actually blindly just applying models with 3 lines of code. Now we're going to try understanding a little bit more what those models are doing and how that can help the business in this case. So what we're going to do is, we know we have these 2 types of problems, type 1, type 2. Someone will not cancel, and we think they will cancel. And we also have this other one that someone will cancel, but we do not detect that. If we go to our marketing department, they will, and this is an assumption I make, they will likely say, this is a bigger problem. Again, I call this person, they say they're fine, we're done. So this is going to be a problem. So what we're going to start doing is try to tune our machine learning models to be less forgiving with these cases and try to detect them earlier, right? If you want, we will try to pass this error to this side, if possible. We're just going to talk about that in a second. So again, we want to reduce this problem of type 2 error. So basically what we're going to decide is we're going to give thresholds, right? So how likely it is someone to churn. Let me show you the data frame we're going to build. There you go. This threshold of what's the likelihood of someone to churn in order to say they will churn. Because what we have right here is a label, it's a categorical variable. We're predicting this person will churn. But behind the scenes, there is a number, there is a likelihood, right? So for example, if the likelihood is 0.75, we say they're going to churn. If the likelihood is 0.749 below, we're saying they will not churn. We are tuning that likelihood, right? What's that number that we use in order to say, right, this person is going to churn or not? We could take it all the way to 0, right, or 1, whatever you want to call it, and basically say no one's going to churn, right? So we're tuning this number we're using in order to improve the error types we're having. So let's say with a bunch of these values, right? So 0.01, 0.2, 0.3, 0.5, what's the likelihood of someone churning? So for example, this person did not churn. This person right here churned. This person canceled. And the machine learning model predicted that the likelihood of they canceling was 0.45, a pretty low score. Again, this is a clear type 2 error. They did churn. They had a 0.45 score in likelihood, if you want, of churning. In that case, if we move this threshold to 0.50 or more, we will have here a type 2 error. The person did cancel, but we didn't predict that. So what we're doing with this model is we're lowering, or what we're going to do now is we're going to lower the threshold in which we become aware of someone canceling, or when we get a little bit psychic, you know, like, hey, 0.45 is actually pretty high. We should move that threshold below that. So this person that did indeed cancel, we will correctly label them as cancel. So just multiple thresholds, there you go. We're gonna see that depending of how you move this threshold, the score of your data frame will be different, okay? So for example, the total score that we had for our regular machine learning model was a 0.81 in total. That includes error types number 1 and error types number 2. What we might do here is we might say, we're going to sacrifice the total score right? From 0.81 to 0.80, which is tiny, it doesn't matter. Let's say it says 0.50 here. We will greatly sacrifice the total score in order to reduce type 2 errors. That's what we're doing right here. And what's going to show here is that we have reduced type 2 errors, but we have increased type 1 errors. And again, this is where the business application comes in place. We will likely talk to our customers and or our marketing department support, and they will help us make this decision. So all true, all false positives and false negatives right here. The score with 0.5, we see that it's a little bit better. And let me see, we have a chart here that shows basically, I'm gonna hide this. There we go. That shows, depending on the threshold that we use to predict if someone has churn or not, we're gonna see that the score diminishes. If the person has a 0.1 score, we will say basically they will cancel. So this is gonna hurt a lot our model. We're gonna have a total accuracy of 0.6, 60%, but they will reduce a lot, of course, false negatives, error type 2. And this makes sense, right? If we predict, we have, if your marketing department comes with this person and says, what's the likelihood of this person canceling? And the likelihood is, well, 10%. And you say, 10%, I'm gonna take action on that. 10% is enough for me to think that this person will cancel. Then you're on this number right here. You're gonna have a ton of false positives, type 1 errors, but marketing probably will be happy. They will be wasting a ton of time calling people that are satisfied with their service. But again, probably that might be better for their department. And here we see how we change that number, right? So the total number of positive values, negative value, positive, false positive, false negatives, and the whole score of the model and how it moves in the threshold. What I want to say here, kind of bottom line, the most important part, and I'm going to answer the question in a second. The bottom line here is the total score of a model doesn't give you the final answer about the model being good or bad. There is tuning to make after you find that sweet spot with your model based on what you want to get. If I am picking a model solely based on its score, then I will probably pick the model with the threshold 0.5 because it gives me the best numeric score, something pretty trivial. I have a 0.81. But we see that here we have a ton of false negatives, something that, again, marketing support, they might be worrying about. If I move the threshold to 0.3, for example, I am close to what is this? 0.78? It's a pretty good score. I mean, 0.81, 0.78, it's the same. But the number of false negatives drops a lot, right? We see a ton of drop in this number that it's very important, the false positive numbers. So again, what I want to say with this is that you can run a machine learning model. If I go up again, we find, or actually, yeah, right here, how we used our multi-layer presenter, how many lines of code it takes you to run a machine learning model. 3 lines of code. Does that tell the whole picture? It doesn't. Anybody can copy and paste, not even write, copy and paste 3 lines of code and run a machine learning model. We have just done it. The difficult part is understanding what it's doing and what could be the impression on the business side. All right, so we might need to tune this model based on the requirements we have on the business. I am looking at something very quickly. I thought we had another model, but that's it. So I'm going to go, now that I'm talking about this, I'm going to go to this question. The background, describe the problem we're trying to solve. That's pretty much what we did at the beginning. We had a bunch of customers who are predicting who's going to cancel or not. How machine learning is going to help you solve this problem? First, when in that merge between data analysis and machine learning, we use decision trees. I consider myself personally decision trees more as a data analysis tool than an actual machine learning tool. Nobody's going to use decision trees to predict something in production. Nobody. I mean, it's highly unlikely. So that machine learning was used not to predict anything, but to understand our data a little bit better. When we were using decision trees, we found that the type of contract they had, the type of service they had, the tenure, these three variables, type of contract, tenure, and services they had were the most important variables in order to predict someone's canceling their service. So that's why machine learning is useful in the analysis process. And then this is something we could, I mean, this is very early, just one hour, but this is something you can take to production. I mean, you can take this thing to production. It's a machine learning model. It's 3 lines of code. People usually think that machine learning models have to have millions of lines of code and be extremely complicated. That is not the case right here. What is it? 3 lines of code, and it works. We tune it a little bit better. We reduce type 2 errors, and we have a pretty robust model to run. And what you should know as prerequisite in machine learning Python before using machine learning to solve this problem, well, that is the whole data analysis, data cleaning, statistics, what pretty much we have in our courses and the learning path. So that's a lengthy question. I hope I have been able to answer that. So in the 5th notebook, I'm going to go very quickly over it, but basically, we're running out of time. But basically, what we are doing right here is there's an error right here. But what we were doing is let me see if I can remove that error very quickly. There you go. So basically, what we are doing with the deep learning side is something similar to what we did before. And we're using Keras and TensorFlow to pretty much run the same multi-layer perceptron we did from scikit-learn and pretty much get the same values that we had. So this is just how training is affecting in terms of times and epochs. And yeah, pretty much the same thing, the validation accuracy of each one of them. So this is pretty much the same thing we did before with a fancier model, which is Keras and TensorFlow. So that is all we have. You can clone the repository. It's right here. Let me see if I can paste it in there. That's in the chat. I encourage you all to clone the model, run through the first notebook that I just glanced over. It's a very important one when we were doing the cleaning, the data analysis one, and then understanding what we're doing, the different models right here using logistic regression, support vector machines, neural networks, random forests. That's standard, just importing different libraries, not libraries, modules or classes. The most important part is understanding the different types of errors we're having and how you can tune that error, that threshold to reduce some sort of error you prefer to reduce. Something interesting too is if you're going to go back again and do the whole process with a balanced data set, so just have the same number of churning customers as you have with not churning customers and see what happens. Just an interesting experiment. We have another question. Customer churn is probably topic that is most popular when we talk about data science and machine learning applications in the business. What other top 3 to 5 scenarios that are popular from your experience in direct application of business, which everything is application to business, right? But I'm saying again, something involving customers. Something that is very interesting is the whole unsupervised learning series. And it's basically, for example, clustering. So you can, in our, let's say INE finds that this user or this client, this student is likely gonna like the data science part, and they're a networking student, so they can recommend something like that. So the whole recommendation systems, but they are all based on unsupervised learning. Clustering methods are a very interesting direct application of machine learning on business. Just recommending customers some other service they might like. That's a very interesting one. Everything in terms of predicting sales, right? So forecasting, which is, I'm right here, I'm talking about completely different categories of machine learning applications we have. It's not the same thing. What we're doing right here is supervised learning. What I said about recommendation systems is unsupervised learning. Sales predictions and forecasting, that's forecasting. It's a completely different thing. We don't use the same models. You could use a linear regression, but that's not the idea. So those are usually the most interesting ones. The same thing to understand how you could reduce costs, how you could grant a loan to a customer, right? That's all based on machine learning models today. It's not something 20 years in the future. Today, if you're gonna go get a loan today, you will probably be running through a machine learning model saying, your score or how likely they're gonna give you a loan or something. So all those are very clear business applications of machine learning. Questions? I encourage you all to check out our courses. We're increasing the number of courses we have. We have a few courses being published soon. We have another webinar tomorrow. Tomorrow. That it's about BioPython. So completely different topic. You might know a biologist, a biochemist that might be interested. So Adriana, who is a very smart person, will be running this webinar explaining how to use Python for biology and biochemist applications. I encourage you all to take a look. And if you're here, you might likely get the raffle for the iPad. Check out our data science pass. The man is asking about subscription price for all countries. I don't know about that, Brittany. That's a good question for you. I think it is.
Okay. So for the pricing for different countries, it all comes out in USD. But if you have any questions or you're worried about it coming out billing weird, you can actually contact us at billing@ine.com. And they can actually put a money order, I believe, place a money order in the correct amount as well as the correct currency. So that'd probably be the best way. If you have any questions, they can also help you with that. Billing@ine.com.
And answering the second question by Neha, if you were a yearly subscriber, you were automatically transferred to INE. If you were a monthly subscriber, we have refunded your money. and there should be a discount code for you to join the Data Science Pass on INE with the same price you had at Remoter. We are honoring that price. So check your email and let us know if that's not clear. All right, Brittany, any closing remarks?
Thank you guys again for attending. You'll receive a copy of the recording later on today, probably around 3 or 4 p.m. And then just be on the lookout for our next webinar tomorrow at 2 p.m. Eastern Standard Time. And we'll see you then. Thank you guys so much.